Hello and welcome. I'm Navneet Kataria. I'm the product marketing manager for Anritsu Benchtop VNA product line. And in this video, we are going to run you through the recently launched spectrum analysis option on Anritsu's Benchtop premium VNA called VectorStar. This is going to be the world's first 70 kHz to 220 GHz single sweep spectrum analysis available. So we encourage you to tell and inform your customers about this functionality. Going straight into the description of the spectrum analysis option, as you all know, this is the VectorStar software, and by default, the VectorStar opens up in the TR mode. In the TR mode, it's basically making S parameter measurements. However, since the spectrum analyzer is a receiver option, if the user has configured or ordered the spectrum analysis option, they can have access to this option by clicking onto the application menu and clicking on the spectrum analysis. Since it's a different mode, by clicking onto the spectrum analysis, it will move from the transmission reflection mode to a SPA mode. By hitting continue, there are few observations that are pretty noticeable. You can see on the left hand side, now it says SPA, and you can imagine that we are using a B2 receiver, basically port 2 receiver, to act as a spectrum analyzer input. Also on the bottom hand side, you can see that the VNA is now acting as a spectrum analyzer. We are sweeping from 70 kHz to 70 GHz with an RPW bandwidth of 1 MHz. If the user wants to configure the spectrum analysis, we have another tab here called as Spectrum Analysis Setup. By entering into this menu, there are two ways that the settings can be done. One is by the individual tabs here. So we have tabs for frequency, scaling, averaging, marker. And also there is a one-stop configuration for our customers called as Spectrum Analysis Setup. By clicking onto this menu, a dedicated GUI opens up, and you can see that we have a tab for SA setting and advanced controls. The advanced controls would be covered in subsequent videos. Going back to the spectrum analysis settings, we have divided the GUI into some subsections for ease of use for our users. So on the left hand side, we have frequency control, wherein the user can configure the number of points, the start and the stop frequency, the center frequency, and the span too. For the users to configure the RPW settings, we have provided another section. So you can see that by default it is into the auto setting, and in the auto setting the RPW settings are to 1 MHz. In the case of manual, this section opens up and the users can add RPWs from 1 Hz to 1 MHz, anywhere in between that. On the right hand side, you can see there is something called as a sweep mode. The spectrum analysis option basically has two modes. One is called as the classical or detected spectrum analyzer sweep, or the other is a VNA-like or measure at specified points only. The detected spectrum analyzer sweep is very useful in case of unknown signals, and the VNA-like, which is measure at specified points only, is very useful and very fast in case of known signals because it sweeps only at definite points. In the case of detected spectrum analyzer sweep, it's more of a classical sweep type, wherein depending upon the RPW filter chunks, the sweep is done. We have also provided something called as an internal source control for our users. And this is a very useful feature because by making use of this, the VNA port 1 can be used as a source. It so often happens that the users, to test their devices, they don't have signal generators accessibility. In that case, through this menu, that is the internal source control, they can basically activate the source of the VNA to act in the CW mode. So now port 1 will be acting as a signal generator. Let's, for example, put it to 20 gigahertz. Now port 1 is actually transmitting a 20 gigahertz signal. In this case, I've connected port 1 and port 2 together using a through. As we already have seen that the B2 receiver, so port 2 is used as a spectrum analysis input port. So if we have to see a 20 gigahertz signal coming from port 1 of the VNA at the spectrum analysis port, port 2, we have to change the center frequency of the spectrum analyzer to 20 gigahertz. And for better view, let's put the span to 1 megahertz. This combination of the receiver and the source can be imagined as a tracking generator functionality. On the bottom hat side, you will also see that we support modular broadband and baseband functionality, which basically means if a customer has already a broadband VNA with him going up to 125 gigahertz, 145 gigahertz, or 220 gigahertz, they can buy this option and their VNA can be converted into a spectrum analysis very quickly and very easily. This software option is field upgradable, so the customer does not need to send the unit back to the service center. Apart from acting as a broadband spectrum analyzer, this option also supports bandwidth functionality, whether it's Anritsu's own millimeter wave modules, or if a customer has a VDI or OML millimeter wave modules. By adding this option, they can do bandwidth spectrum analysis in those higher frequency bands as well. We also have enable zero span mode, enable automatic IF gain, enable image rejection, and enhance spur reduction. Once all these settings are configured and I hit done, you'll see that all the settings change automatically, and we have a 20 gigahertz signal coming from port 1, and port 2, which is acting as the spectrum analyzer, is receiving the signal. In the next video, I will be explaining more on VBW, averaging, marker, and other functionality of the spectrum analyzer mode. Thank you for watching.